All right, lesson 8, arcs and chords. So we're going to continue with the arcs and we're going to incorporate chords with these chords. Remember, are those lines that cut across a circle from one point on a circle to another point on a circle. Given a circle, or given circle A with arc BC equal 54 and CD, angle CDB congruent, CDB congruent to DBE, DBE. So they're saying that those are congruent, right? So let's go ahead and mark those so we remember those two there are congruent. Find arc DE. Well, this is going to be half of 54, which is 27, so therefore this is 27, so this has to be twice 27, which is 54. So that wasn't so bad. What do you notice in the diagram at the right? Well, you notice a couple of parallel lines. That's going to make things interesting. What seems to be true about the arcs? It appears that the arcs that are cut off seem to be the same size. So if I draw CD, they're saying if I draw from here to here, we know that these angles are congruent, right? So this inscribed angle here, let's say this is x, since these are congruent, since this is x over 2, and maybe I should do that differently. Let's call this x, right? So that makes this 2x. Therefore, these are congruent. This is x. Those are alternate interior angles. So this is 2x. So therefore, we know that the angles are congruent, and we've proven that the arcs are congruent. Arcs between parallel chords are congruent, and they want us to prove that. We're not going to do a two-column proof, but you get the idea. If two arcs in a circle have the same measure, what can you say about the quadrilateral formed by the 4 endpoints? That's interesting. Let's go ahead and draw this and see what we think. All right, so here's two arcs that are congruent. If I were to connect the endpoints here and here, right, and here, and say here and here, and here and here, what can you say about this? Do we end up with something we recognize? Well, we know that this looks like a parallelogram. These have to be parallel. So you end up with a quadrilateral where you have at least one pair of parallel sides. Okay, so next we're looking at find the measure of arcs CD and ED. We know that we have parallel lines, so that means if this is 65, this is 65. Arc CD has to be twice that amount, or 130. Arc ED is here. That's interesting. So we know that we have a diameter here, right? And we know that these two arcs have to cut off the same amount, 130. So we know 180 minus 130 has got to be 50 degrees. So we end up with 130 and 50 degrees. Measure CB and equals measure of ED. CB and ED. Therefore, the chords are also going to be equal. Um, then they got the three arcs here that are in ratio of 1 to 2 to 4. Remember the ratios. BC is x, BD is 2x, and EAC here is 4x. Now notice they didn't give us this one, but we already know that those two are equal, so we can call that x. Now before I answer these questions, let's put a value to x. We know that x plus 2x plus x plus 4x equals 360. 348x equals 360. Therefore, x equals 45, and you can check my arithmetic on that. So we now have, let's see, angle BCF. B would be BCF. They're talking about this is going to be half of that. Well, we know x is 45, so this has to be 45, right? This is x. EDF is this angle, which is related to this arc, right? That means this is 2x. Well, 2 times 45 is 90. That means you know this is a diameter, just saying, right? CFE. Where's CFE? CFE. This angle here. Wow, that's interesting. So let's take a look at that. We know this is a right angle. That's 90. And so is this, for that matter. That's 90. We know this is 45. So doesn't this also have to be 45? Which means this angle here is 135. So again, sometimes you get puzzles to put together. And you got to pay attention to the simple thing that this was a diameter made that problem a little bit easier to work. All right, we got an exploration here, and they're implying some things here. So in the diagram, we got two arcs that are equal. Prove that the chords are equal. In other words, they're going to ask us to go through and say, hey, go ahead and connect these radii. If this was x, then this is x, and this is x because this is also x, right? We know these are isosceles triangles, and therefore by angle or by side angle side, those triangles are congruent. Therefore, we can conclude that these chords are congruent by CP, CT, C. Side angle side, things like that. Pretty cool. And then they're asking us to do this again. If the chords are congruent, prove that the arcs are congruent. And again, they ask us to go ahead and connect these radii. Right? We know those are congruent, and we know the chords now are congruent. So these triangles are congruent by side, side, side. That's a 3. Therefore, we know that these central angles are congruent by CP, CTC. And because the angles are congruent, therefore we can conclude, the central angles are congruent, therefore we can conclude that the arcs are congruent because central angles are congruent. All right, a couple more here just to finish things off. to deal with theorems, they're asking us to identify, is this because the arcs are parallel and the chords are congruent, or are the congruent arcs have congruent chords, or congruent chords could have congruent arcs? So right off the bat, QR congruent to ST. Let's see how much time I have. I got a few minutes left. Okay. QR and ST are congruent. If the chords are congruent, then the arcs are congruent. And now I can go ahead and say, hey, look, I know then that 4x is equal to 3x plus 22. So there, subtract 3x and we get x is equal to 22. Theorem used is if chords are congruent, then the arcs are congruent. That's 3. Value of x is 22. Measure of QR is 66 plus 22 is 88. Over here, notice that we have congruent chords, therefore congruent arcs, right? So that's going to be 3 again. I know that these all add up to 360, right? So x plus 220 equals 360. 2x equals 140. X equals 70. So arc FGH is equal to 140. Twice 70, right? That's blank. Okay. In this case, we are told that the arcs are congruent, therefore the chords are congruent. That's 2. Therefore, 5x is equal to 3x plus 6. 2x equals 6. X equals 3. If x equals 3, then AB equals 15. All right, 5 times 3. And 11, the last problem here, we have parallel lines. So clearly this is 1. Arcs between parallel lines are congruent. Therefore, 4y minus 1 is equal to 2y plus 7. Subtract the 2y, we get 2y over here. Add the 1, we get 8. Y is equal to 4. Therefore, arc FA is 16 minus 1, or 15. All right. Those are important theorems to keep in mind. Write them down. Good luck.